The derivative of tan x is equal to secant squared x. But how do we get there? So we're going to show this by setting up the Newton quotient for the derivative of tan x, letting the limit as h go to 0 of tan of x plus h minus tan x over h. Now, to do this, we need a couple things. We need to have an identity for tan of alpha plus beta. So I've written that up there in green. So we're going to replace that tan of x plus h, and we're going to use an identity to be able to tease out a tan x out of there. That will allow us to simplify that minus tan x in the numerator. Secondly, in the first part of this question, we established that the limit as h goes to 0 of tan h over h is equal to 1. So we've proven that, and there is a proof for that. But essentially, we're going to use this as an identity, and we're going to then evaluate the limit using that identity. So the first thing is we want to express this limit and take that tan of x plus h and apply the identity to this. So we're going to end up with tan of x plus tan of h. Okay, so that's going to be the alpha plus beta part of this. And then it's going to be in the denominator 1 minus tan x times tan of h. Okay, so all of this then is just the application of the trig identity. Then we're going to have minus tan x, and that's all over the h, which we're going to let go to 0. Okay, so to simplify this, we need to group together we need a common denominator. So I'm going to write it like this. So the limit as h approaches 0, and we're going to end up with tan of x plus tan of h, and then minus, so we need to put this all in one denominator, minus tan of x times 1 minus tan x tan h. Okay, and this is all over the denominator of 1 minus tan x tan h. And then I'm going to put that extra factor of h in the denominator. Okay, so I've got now this expression. I can expand those brackets and I can get rid of that. I end up with generating a minus tan x, which is going to cancel with a tan x. So this is kind of what we want. So we have the limit as h approaches 0, tan x plus tan h, minus, when I expand those brackets, tan x plus, so it's negative times the negative, so we're going to plus tan squared x times tan h. And that's going to be all over 1 minus tan x tan h, and that divide by h is what we want to get rid of. So we can see that some terms are going to cancel out, so tan x, the minus tan x, and I'm left with tan h plus tan squared x times tan h. Now, the nice thing about that is I can factor out a tan h, and then we're going to be able to generate our identity that we need. So limit as h approaches 0, so I'm going to factor the tan h out, and I'm left with 1 plus tan squared x. So I factor the tan h out, so maybe I'll just highlight that. That tan h here and that tan h here got factored out of that expression. And then what's left in the denominator? So I'm going to put that h over here, and 1 minus tan x tan h. So really the problem is that divide by h, but what we can do then is we can group that all together. We can group this all together, and there's my identity. So I'm going to end up with the limit as h approaches 0 of tan h over h, okay, and that's going to end up being equal to 1, and I have the limit as h approaches 0 of 1 plus tan squared x. Well, that's the same as secant squared, and in the denominator I'm going to have 1 minus tan x times tan of h. Okay, so the key now is that if I let my h go to 0, I can plug in 0 into that tan, and the tan of 0 is equal to 0. And what's going to end up happening is that's going to end up being tan x times 0, which is 0. So it looks like this. So I'm just going to evaluate, first of all, that tan h over h limit. Okay, again, we established that to be equal to 1. So that's going to be equal to 1 here. I'm going to then apply this limit. I'm going to substitute in 0 into this expression. And so I end up with 1 plus tan squared x over 1 minus tan x times tan 0 works out to be 0. So what I've done here is I've just evaluated my limit by substituting in. What I've substituted in is that h is equal to 0. I've generated this 0 in the denominator, and now I can evaluate the rest of this limit. It's going to be 1. I'm just going to take that 1 out. This is going to be 1 plus tan squared x, which is really secant squared. And it's going to be 1 minus tan x times 0 is 0. So this works out to be 1 plus tan squared x. And using our identity, we get secant squared x. So we've shown then, using the limit, or the definition of derivative, that the derivative of tan x here is equal to secant squared x.